I hope you all have enjoyed our academic presentation so far. My name is Peter Meredith and I have done the video editing and production for everybody's presentations. So today I will only be talking about one thing, which is one of my favorite things, called quantum computing. Before I can explain how quantum computing works, we must first take a look at computers. Computers talk and communicate using a system called binary, which is made up of zeros and ones. These are called bits. A bit can either be a 0 or a 1. When a computer puts 8 of these in a row, we call it a byte. So I can string 8 zeros in a row, and we would call this a byte. Now any of these can be a 0 or a 1, and we can write them in any combination. We end up having 256 different combinations of zeros and ones that we can fit inside of a bit. Now, you might be thinking, 256 is not a very large number, and it is not. But this is not how a computer counts. This is what a computer uses to transform into different things. We can set any of these combinations to mean anything that we want. If we think of a bit as a quarter, with one side heads being a 0 and the other side tails being a 1, we can think of lining up our quarters, heads and tails, in different combinations. Now supercomputers use quantum bits, which are called qubits, and they have two special properties that make them different than regular bits. The first one is called superposition. Using quantum mechanics, we can put a qubit into a superposition, which means it is both a 0 and a 1 at the same time. If we think of it like our quarter, we have a quarter heads or tails, 0 or 1. If we take that quarter and we spin it on the table, and I said, is that quarter heads or tails? You would say, well, I don't know. We have to wait until it stops spinning and then we can find out. Quantum computing is kind of like a spinning quarter. When an electron is put in a superposition, we say that it is both a 0 and a 1 at the same time. It is in the two states called spin up and spin down. What does this even have to do? How is this cool? You might be thinking. But this is what makes it very cool. I can take 8 quarters and I can make 256 different combinations of heads and tails. That is pretty cool. But if I'm a quantum computer, I can spin all those quarters and I can represent all 256 combinations at the same time. The second cool principle that qubits have over bits is called quantum entanglement. It is extremely complicated. Einstein even called it the freakiest thing he's ever seen, and nobody really knows how it works. But basically, it is a way of combining two bits together where they are mathematically related, which means we can do lots of cool things with them. I have no idea why or how that all works, but basically it's taking two electrons and mixing them together. In order to create a quantum computer, the room has to be extremely cold. Qubits are normally kept at a whopping 0.01 Kelvin, or negative 273.135 Celsius. To put that in perspective, 0 Kelvin is the coldest thing you can ever have. 0 Kelvin is when it is so cold that atoms stop moving. Quantum computers are only at the beginning of their stages. Currently, the best application of quantum computing is for simulation. We theorized that we could simulate how chemical reactions work. And currently, IBM, with the largest quantum computer of 53 qubits, is simulating weather. They are using their quantum computer to simulate how the weather works and how everything changes on a global standpoint. This has been my presentation on quantum computing. I hope you had fun and learned a lot.